Morning. So today's talk is on plumbing terminology. We've been asked by a couple of plumbers some of the phrases, and we've put together a list of phrases and abbreviations and things like that that do come up in the plumbing industry. And obviously it makes ordering easier for plumbers if they can tell people exactly what they want. And this is just a brief overview of some of the phrases and things that come up in the plumbing industry. When it comes to doing COCs and audits, some of the phrases will be on the COCs, and it certainly helps if you know what the guys are talking about. And if you're going to order product, or if you've been asked in a quote to do certain things, it'll help if you know what you're talking about and what the things mean. So getting right into it, we're going to start with pipes, and there are many types available on the market. But we're just going to chat about probably the two main pipes, which are either metal or plastic. We're not going to chat about concrete pipes and glass fiber pipes and things like that, because the majority of projects are done in either a metal or plastic pipe. So the pipes that fall into a metal category would be copper, steel, stainless steel, galvanized. Those are the commonest metal pipes you get. Copper probably is mostly used for hot and cold water and some bigger installations, and most plumbers will certainly be au with copper. And then galvanized is used generally at the moment for fire mains, and I know that in Durban and places like that, galvanized is not used, but galvanized certainly is still used a lot in South Africa. In the olden days, it used to be used for hot and cold, but very few people use it for hot and cold in South Africa presently. Stainless steel is becoming more and more locally acceptable. And in Europe, they have replaced a lot of the galvanized work with stainless steel. So something to look out for. Stainless steel probably a little bit easier to install than galvanized. Majority of stainless steel relies on a crimp fitting or a press fitting, or the more modern stainless steels rely on a crimp fitting or a press fitting, as I say. And then with copper pipes or with metal pipes, you get a class rating. So you'll get a class 0 and you'll get a class 1 and 2 on copper. And that refers to the wall thickness and what you can and can't do with the pipe. Class 0 is generally for inland, and class 1 and 2 is generally for coastal regions because it is more resistant to corrosion. HDPE pipes are certainly becoming the norm for water mains, and a lot of HDPE is starting to be used in drainage as well. I know in Gauteng, where there are dolomitic areas where the soil is unstable and things like that, they are insisting on HDPE drainage pipes. With HDPE, there's a PN rating, which refers to nominal pressure, and that gives you what class, or the PN rating gives you what pressure it can take. And included in that is a safety factor of 1.25. The reason why there's a safety factor is that this is so you can get to the life expectancy of 50 years on an HDPE pipe. So they make the pipe stronger than it needs to be so that it can last longer at these pressures, and the target is usually 50 years. So if it's a PN12, it has a rating of 12 bar. And as I said, HDPE is used in drainage and water. In drainage, it'll be a lower PN rating, and in water supply, it'll generally be a higher PN rating. Quite a lot of people don't know, but HDPE can go right up to PN25 in certain instances, and some projects require PN25. Sometimes you might get to a project where the engineer is not referring to it as a PN rating, and he gives you an SDR number. When we refer to SDR numbers, the lower the SDR number, the higher the pressure. So it's the inverse to PN rating. So you'll get an SDR 26, which is about a class or a PN6 pipe, whereas an SDR 11 is a PN12 or PN16 pipe. And there are several jointing methods in HDPE that we also use. Then, similar to HDPE, PVC pipe. PVC stands for polyvinyl chloride, and we also get UPVC, which is unplasticized. This is generally used for pressure pipes, and it has less flexibility, but becomes a much more rigid and harder pipe. And then we also get a pipe called PVCO, which is very big in Europe and is coming here. I know that Bantu make PVCO here, and that is the way that they orientate the pipe when it comes out, and that gives an even stronger PVC, or stronger and more flexible PVC product. PVC comes in different classes, like a PN number. This refers to your pressure rating on the pipe. And then we move on to hot and cold water plastic pipes, and we get mono and multi-layer pipes. Mono-layer pipes are single extruded pipes, usually your PPRs and those sort of pipes. So your those green plastic pipes and blue plastic pipes that are quite rigid. And then we get multi-layer pipes. And there are several types of multi-layer pipes. We get some multi-layer pipes that have an oxygen barrier inside, that are basically pure plastic, but have a small or a very small layer of usually an ethyl vinyl alcohol inside, which stops oxygen going through the pipe. So we don't, and that's usually used for underfloor heating and for radiators. And then we also obviously get a whole lot of multi-layer pipes that have metal inside. Aluminium is the most common form in a multi-layer pipe, but you also get multi-layer pipes with copper and other things inside them. And please remember, guys, that the aluminium or the other metals that form a layer, they're not the whole pipe. And this doesn't change the fact that that pipe still falls under plastic pipe standard and approval and cannot be used for safety valves and solar installations at all. Even though the plumber, or you might say, but it's a metal pipe, it doesn't count as a metal pipe, and it's the plastic that forms a pipe. The metal is there for stability, so it is not able, or you're not allowed to use it for safety valves and solar. And the other thing that's quite important to look at, especially when you're coming to COCs and things like that, is that plastic pipes are not approved for installation in direct sunlight and need protection. Then if we go into the types of joints we get a screwed fitting, which if you look at the picture there, you can see a galvanized pipe there. And screwed fittings are very common in South Africa, and it's also a way that we transition between different pipes. So we'll have a male adapter possibly coming from HDPE, and then we'll put a female adapter or a female socket onto that to go into copper or into galvanized. And that is how we transition between pipes. In South Africa, we use a thing called BSP, which is a British standard pattern. And we either have a tapered or a parallel thread. A tapered thread is a curved thread or a pointed thread, usually found on the end of a galvanized pipe, for instance. And a parallel thread is a straight thread. Most male and female adapters are usually parallel threads. And as I say, tapered is usually where you've threaded the pipe, it becomes a tapered thread. Then we can also join with butt welding. Butt welding is when we put two pieces of pipe against a hot plate. And once they are hot and melted, this would obviously be, generally speaking, on plastic pipes. We can then push them together to form a joint. And we also then could use a spigot or a socket joining, where a pipe is generally, again, heated on a hot plate, and then the female inside is heated and the male outside is heated, and then those two are pushed together. And if we're not using heat, quite a lot of that is done with glue, especially on the PVC side. We then also get on to joining pipes with electrofusion. Mostly it's HDPE, but PPR and a couple of other pipes can be joined with electrofusion. Electrofusion is a socket or elbow or whatever fitting you need, and it has very thin little wires built into the fitting, and then these are connected to an electrofusion welding machine, and that welding machine passes a frequency through the wires which create heat, and those wires then, or that heat then melts the joint, or melts the the outside fitting and the internal fitting, and that creates a welded joint. And those welded joints are very, very strong and a very efficient way to join a pipe, because basically once your installation is done, you have a continuous pipe from the start to finish, because it's all welded together. Then we have crimp joints. Crimp joints usually use a machine, but we also quite often use a tool on smaller sizes, and that goes over the crimp fitting, and when the machine or the jaws are closed over that fitting, it crushes that crimp down onto the pipe and changes the shape of the pipe and the fitting to create a very, very tight and strong joint. Stub and flange is also a way of joining, generally on bigger sizes. A stub is installed on the end of the pipe with a round flange behind it, and then this is tightened to either a valve body or to another flange with nuts and bolts, and used especially on bigger diameter pipes. And then the flanges come in different tables. So if ever you see on a bill of quantities or something where it refers to a table 16, that is, or a table, whatever, table 8, that refers to the number of holes and the thickness and strength of the flange, so that we can join different fittings together to cope with the pressures that are going to be required and the strength that's going to be required. If we can go on to abbreviations a little bit, quite a lot of abbreviations come up in plumbing. The first one, probably the most common, is PRV, which is a pressure reducing valve, and that's usually used in connection with a hot water cylinder or a geyser. Then we have a pressure control valve, and that is to control the pressure, often used at the start of a townhouse complex or something like that, or a zone where you want to reduce the pressure or control the pressure going into the complex, and then each geyser would have a pressure reducing valve. Then we also do an RPZ valve, and this is where you must be very careful when you're quoting, guys. If somebody asks for an RPZ valve, it's very different from a pressure control valve or a PRV or a pressure reducing valve, as it reduces pressure, but it is also used to prevent backflow and contamination of water supply, and it does that by using pressure differential to seal something if the pressure reduces on one side. There's quite a lot of terminology involved there. I know that if you listen to Patrick Gordon on his tech talks, he goes into RPZ valves in quite good detail, and I would really recommend that before you ever quote or ever install one of these, that you chat to somebody at our ops, so probably Patrick or one of his group, and he will be able to guide you on that. And then another valve that comes up quite often, especially in bigger projects, is an RSV valve, which is refers to resilient seated valve. And this is for a valve that it has a very strong face and a very strong internal design, so that it can be turned on and off after 5 or 10 years and still work perfectly. It's designed for very seldom use, for instance, on a water main in a suburb or something like that. Then we go on to, if you're doing a bit of projects, you would have seen a JBCC, the Joint Building Contracts Committee. This was a group that was established to try and create a standard contract for people, or for all contractors, that is fair to everybody. And the JBCC contract is now the standard way in which most projects are run in this country. Most of them, when you read the thing, it'll say done to the JBCC method or contracts way. Another thing that has come up a lot in plumbing recently is practical completion. And it's something that plumbers must be very aware of, especially when they're working on big projects, because practical completion for a plumber generally means that the project needs to be finished anyway. And practical completion for a plumber is generally quite different to the main contractor, because you as a plumber will have to be finished anyway. So when you making sure you're getting paid and things, because practical completion is a performance milestone that gives you payment, you might need to be entirely finished, whereas the contractor will only be claiming for practical completion. So you might only get paid 2 or 3 months later when the project is actually finished. Meanwhile, you're finished before practical completion. So please be very careful as a plumber, because you could be relying on others to complete before you get paid on a project. And that's something to bear in mind when you're doing your costings before you start. Other abbreviations that are going to come up in quoting work or when you're tendering for work is BOQ, which is a bill of quantities, and that usually lists the requirements for the quotation. And care must be taken when you're replying to these things to do as much detail as possible. The more detail is generally the better. List what you're going to do, because then if there are changes, you are covered. And a lot of bill of quantities will ask you prices and have a 0 next to it, because they're taking it as a case by case where they might need it or might not. So make sure when you're pricing those items that have 0 that you get those prices right, because they could come into the project later. The other thing that's becoming very big in the plumbing industry is BIM, building information modeling. And this is done with most new builds. I know in Europe that no public building in Europe can go out for tender unless there's a full BIM plan on it. And that gives you the ability to model a building in 3D, and for you to actually walk through, virtually walk through the building and have a look at how everything's going to fit together. And with some advanced versions of BIM or BIM, the pipe manufacturers have actually added objects to it. So the designer can use the correct elbow as per the dimensions and per the sizes to form a very accurate design. And they can use it in, for instance, a duct, and they can check that all the pipes will fit into that duct and have enough space and everything will work correctly. They can design that before they start, and it means you as a plumber will be getting a very, very accurate bill of quantity to price on, and it'll also be able to troubleshoot problems before they start, because you will know that your pipe will fit in the same duct as the air conditioning guy, and all of those sort of things will all work together, so you will be able to get everything in there. A couple of other little things that people maybe need some assistance with. A backflow preventer, it's also a non-return valve. Non-return valves usually referred to pressure lines, and backflow preventer for sewerage, and that's to stop the sewer or the sewerage coming back up the sewer lines. Then we've got a concentric reducer, which is the reducer on the bottom right here. If you look at it, it comes out the center. And we have an eccentric reducer, where the reducer comes out the side of the pipe, if I could put it that way. Jason, I saw you raise the hand there. Do we need to do something, sir? Anyway, we'll move on. Then we also can chat about condensate. The discharge from a fridge or a heat pump or aircon needs to be taken care of, and it needs to go into drain. And this is a concern in South Africa, as it can cause the spread of disease if it's not properly trapped or taken care of. So those are things that we need to just look at. And again, in the COCs, these are things that are going to start coming up. If we look at traps, a trap is designed to stop the smell coming back up the sewer. And one of the things that happens with traps is siphonage. And siphonage is when your drain is not installed correctly, you run the risk of pressures changing and creating a failure in the trap. If you look at that picture on the right there, that is a self-siphonage. So that means that the water flow through the trap is too fast, and that creates a suction. And like when you're sucking petrol out of a can, it keeps sucking, and until air gets in there and it breaks the seal, your trap is going to keep siphoning. And once the air breaks the seal, then we're going to have smells coming back to the building. So to prevent this, we use a thing called venting. And to vent a drain lets air in and out through a designed method. to prevent failure of the traps. And then obviously a P and an S trap is the shape of the trap. That trap there, if you look at it, is like a P on its side, and an S trap would be similar to that, but in an S shape. Some of the other plumbing terms that come up is pressure or head of water, and this is the amount of force exerted by water on the pipe and fittings, and it's measured in bars or kPa, and is increased by 1 bar for every 10 meters of height above the fitting, hence the reason why water towers are at the top of the hill and why we need pressure reducing valves. Static pressure and dynamic pressure is also quite important, because static pressure is the amount of force exerted when the system is at rest, and dynamic pressure is the amount of force exerted when the system is in use. And this changes constantly depending on usage and pipe sizes and things like that. And a lot of thought needs to be given to those sort of things to make sure you have enough volume of water at the end of the line when you open a tap, which then brings us to flow rate, which is often confused with pressure, but is how much water you get out of the system. And high pressure does not automatically give us a good flow rate. As I said, it depends on pipe sizing and lengths and bends and all that sort of thing that go with pipes. Then probably one of the most important things at the moment is plumbing. In plumbing terms is a couple of terms that are important in the plumbing industry at the moment. The PIRB is the Plumbing Industry Registration Board. The Institute of Plumbing, or IOPSA, is the Institute of Plumbers, and those are separate items. The one is the official registering body, and the other is the institute or the group of plumbers. And then we have the COC, which is a certificate of compliance. And this is something that quite a lot of people maybe don't grasp quite perfectly, but if you issue a COC, it's to fill it in and to give it to your client or to give it to the building occupier. And then that is not the end of it. You need to log it. And logging a COC is the process of now taking that COC and logging it with the PIRB after filling it in and giving it to the client. And that way, the PIRB can randomly choose, and I think they aim to choose 5% of all COCs that are logged to be audited. And when they audit a COC, an auditor is appointed by OPSA, and he confirms that you completed the installation correctly. And if you haven't completed the installation correctly, you would be given a notice to repair or refix, and he would guide you through what you needed to do. Thank you for attending, guys. We appreciate it, and I hope we've managed to clear up some of the terminology in the plumbing industry.